Welcome back, everybody. So we are in Unit 9 now. There are 12 units, so we're nearing the end. This is going to be about angles and circles. The next unit will be about segments and circles. So hopefully by the end of this lesson, you'll be able to distinguish between interior, exterior, central, and inscribed angles, be able to identify parts of a circle, and be able to solve problems involving various parts of circles. Mostly with angles, or all with angles in this section, as I said, but later on segments. So you can see some key vocab there, and we'll definitely talk about those next unit as well. All right. So some of you may already know some of these terms, but I want to point out a few of them. We have a radius. A radius is from the center of the circle to any point on the outside. So there's really an infinite amount of radii in a circle. Think about spokes on a wheel. We have a diameter that's the whole way through a circle, but it has to go through the center point. We have a chord that goes the whole way through a circle, but it doesn't necessarily have to go through the center point. So a diameter is always a chord, but a chord isn't always a diameter. Notice the chord starts and stops, okay? It has an ending point on either edge of the circle, or the circumference of the circle. A secant is like a chord, but it keeps going. It's a line, whereas a chord is a line segment. And a tangent is a line that just barely touches a circle. It touches it in one point. So we also have different types of angles here. We have central angles. Notice the vertex of this angle is right in the center of the circle. For an inscribed angle, the vertex is on the circumference of the circle. Those are the first two we're going to talk about. Now, when we measure arc here, if we have a central angle, the arc is going to be the same as the center angle. And if you think about that, there's 360 degrees around a circle, whether that's on the inside or whether that's on the outside. But an inscribed angle, the angle is going to be half the arc, or if we would call the angle y, the arc is going to be twice the angle. Intercepted arc comes into play by taking the legs of the angle, and whatever arc is intercepted by that, that's the intercepted arc. So later on, we'll talk about internal angles, usually created by two chords or two secants. And then we'll talk about external angles, which are created by either two secants or maybe a tangent and a secant. Now, on these problems, we have a couple steps, okay? And it says, find the measure of the arc or central angle indicated. So I'm going to zoom in a little bit. So it says here, find the measure. Now this is angle. So find the measure of angle FEH. Okay. Now we also know that up in the directions it says assume lines that are appear to be diameters are actual diameters. So let's use that fact. So right here I think I have a diameter. Now I said earlier the whole way around the circle is 180. A diameter cuts the circle in half. So that means from here to here has to be 180, but it also means we have a straight line here. And a straight line makes 180 degrees. So if this angle right here is 90 degrees, 180 minus 90 means this angle would also be 90 degrees. Okay? For number 3, I'm looking for now, this little symbol up here means arc. Okay? And if it uses 3 letters, that means it's going to be bigger than 180 degrees. So 3 letters basically means bigger than half the circle. 2 letters would mean smaller than 180 degrees. If you look at number 2, I believe, which means less than half the circle. So if it's 3 letters, I start at A, I go around to D, and then end at B. So it's that whole arc I'm looking for. Now I have another diameter here. Remember we said that cuts the circle in half. So this whole thing right here, actually I'm not going to use that one. I don't think that one's going to help. I'm going to use this one, cuts the circle in half. So this has to be 180 degrees, which means this would be 180 degrees too because that angle's in the center. So if I want to find this whole green arc, kind of like the crust of a pizza, I think I would do 180 plus 45 plus 77. Okay? So 180 plus 45 plus 77 is 302 degrees. moving on to some inscribed angles. Now these ones can get a little tricky, but remember what makes like this 54 inscribed is that the vertex is on the circumference of the circle. Okay, so this angle was made by those two lines. So that means this arc right here would have to be double that. So for central angles, the arc is the same. For inscribed angles, the arc is double. So now if I look here, I have this line that goes through. That's a diameter, so it cuts the circle in half. So what's left over between the red and the green arc would have to equal 180. So what's left over must be 180 minus 108, which is 72 degrees. If I look at something, I'll do number 6 here for you. So I know this arc and I know this arc, right? My suggestion would be, why don't we find what's left over for this arc? So those 3 make the whole way around the circle. So to find what's left over, I could do 360 minus 104 minus 116. So 360 minus 104 minus 116 would leave 140 degrees for this. Now, if I look at the question mark, which was the angle, what I'm actually looking for is this angle. So that blue arc is its intercepted arc. Since it's inscribed, the vertex is on the circumference, it has to be half of that. Okay, so that is central and inscribed angles. Now, on your formula sheet, you have 6 different formulas for circles. And you can see those all there. So this is where knowing some of those vocab terms is going to be key. Now, I want you to notice something, that some of these, especially these kind of last 4, or however you want to think about it, have 2 different formulas. The ones that deal with x's and n's are the ones that we're going to worry about for angles. And if you look, almost all of them, well, 3 of them are the same, and then 2 of them are the same. So there's really only 3 different angles there. So let's try to put those into play a little bit. So just a reminder, here's our different vocab terms, just in a different picture. Okay, if you need to look back on that. So let's look at number 1. If I look here, I have a line that goes through a circle but keeps going, and the same thing in the second one. So I think, and let me zoom in here, see if this is too much. So I think number 1 is going to be my 2 secant formula. Okay. Then if I look at my 2 secant formula, the formula for angles is x equals 1/2 m minus n. Now when I look at that formula, my x is the angle inside, and you have to be careful with that because sometimes there'll be an x in the problem. My m is kind of the away arc, and my n is the closer arc. So x is what I don't know. In this case, it's not always. 1/2. My m, I said, was 135. And my n was, I shouldn't have wrote that. My n, I know my n. It was 55. So 135 minus 55 is 80. I take half of 80 and I get x equals 40 degrees for that one. So let's zoom back out here and let's do a different one. How about, well, number 4 is definitely going to be a tricky one. So we'll do that one together. So let me zoom in and go across here to number 4. All right, so if I look at number 4, notice those lines are both sort of barely touching the circle. So that's what we call 2 tangents. Each one of those is a tangent. The formula for 2 tangents is, again, x equals 1/2 m minus n. Now, in our formula, and I may need to zoom out just a touch. In our formula, our m is our bigger arc. Our n is our smaller arc. And our x is our angle that's made between those 2 tangents. So that's how I'm labeling this. But really what I'm missing is this. So instead of confusing, I'm going to call this y. Now I can't solve an equation with 2 unknowns. But if I think about this as y, then that means this has to be everything but y. So I'm going to call this 360 minus y. So for the red is y, that means the blue has to be 360 degrees minus whatever the y is. So when I plug stuff in, I actually know my x in this case that's in the formula. It's 63. My m, and I'm going to put this in parentheses because it's a binomial. My m is 360 minus y, and my n is y. So it looks a little tricky there. Now, the best thing to do to get rid of a half and multiply by something, we can divide by a half, or we can multiply both sides by 2. So if we multiply both sides by 2, that cancels out the 1/2 over here. And if I multiply 63 by 2, I get 126. Now, inside parentheses here, I have to combine like terms. And I know I'm using a lot of colors here, but I have a negative y and a negative y. So that actually becomes negative 2y. So what I'm going to do now is solve this equation. So I'm going to subtract 360 from both sides. So 126 minus 360 equals negative 234 equals negative 2y. So I divide by negative 2, and I would get y equals 117. Now, I know that that's kind of tricky. These are probably going to be some of the harder problems that we do. All right, now we have some expressions. So let's do one with like number 6 that has 2 chords. So the 2 chord formula is the only one that's a little bit different. And it is x equals 1/2 m plus n. Okay? So like my x is my thing in here. My m and my n in this case are kind of interchangeable. So go reference the formula if you have questions. So my x is 10x minus 6. I said my m was 78 and my n was 70. So 10x minus 6 equals half 70. 8 plus 70 is 148. 10x minus 6, half times 148 is 74. So I add the 6 to both sides, I get 10x equals 8, which means 10x equals 80. If I divide by 10, x equals 8. Let's see, we'll do another one. I know this video is a little bit long. So this is back to, let me zoom out a little bit. Okay, so this goes back to a 2-secant formula. So x equals 1/2 m minus n. So this is my x, this is my m, and this is my n. So my x was 30. My m was 116. And I want to make sure I put this in parentheses. Like that. So I'm going to multiply, I want to get rid of that half. Anytime I have an x inside the parentheses, I want to get rid of it. So I'm going to multiply both sides by 2. That cancels out the half. I get 60 equals. Now, when I combine like terms here, I have to kind of distribute that negative sign through. So this is actually negative 56 minus x. So 116 minus 56, I believe, is 60. So I get that. If I subtract 60 from both sides, I get 0, which I know kind of freaks people out. That's like a negative 1, so I divide by negative 1, and I would get 0 equals x, which is fine because when I plug that in, I'm still going to have 56 as my n. All right, so these ones are pretty much all the same, except you have to plug it back in after you find it. So let's look at number 10. It is a 2-chord problem. If I go to my formulas, it's x equals 1/2 m plus n. My x is always my angle, so that would be 39x plus 3. So that's going to equal 1/2. And if I'm adding things together, I don't really need to worry about the parentheses as much. Okay? So because there's x's on both sides, it doesn't really matter how you get rid of the half if you multiply this side by it or if you go ahead and multiply by 2 on both sides. But I have to remember that I need to multiply both of these things by 2. So that would give me 78x plus 6. I combine like terms in here. Okay, now I need to move all my x's to one side. So I get this. That should be plus 1x. Subtract my 21. and I get this. And I think, look, I kind of messed this up, didn't I? This wasn't 21 right here. I don't know what I was combining. So let's go back and fix that. Just like you guys probably do. I make some mistakes. This is a positive 4 and a negative 17. So this should have been 3. A positive 4 and a negative 1. That should have been 3 there. So I get 3. I should have subtracted 3 from both sides and got 3 equals x. Okay, so just be careful. Let's see. We'll do number 11, I guess. Actually, let me go back here too because I forgot to plug that back in. So I wanted to find angle FEG, which was this angle right here. So I should have done 39 times 3 plus 3. So my final answer would be 120 degrees. All right, for this one, I have a tangent and a secant. So the formula is x equals 1/2 m minus n. My x would be this. My m would be 205, and my n would be 13x. So I'm going to go ahead and multiply both sides by 2. Remember, I got to do both of these things, so that would be 30x minus 10. So I'm going to add the 10 over here. That cancels out. I'm going to add the 13x over here. I get 43x equals 215. I didn't write 43, did I? I just wrote 4. 43x. So if I divide 213 divided by 43, 215 divided by 43. Oh man, x would be 5. If I'm trying to find our EG, that was this one. So I would do 13 times 5, which would be 65 degrees. That would be my final answer. All right. Finally, this one tells me arc DGE equals 2x plus 200. Now for this one, I do have an inscribed angle. Look where that vertex is at. So I know that this green arc right there has to be double the angle. So this would actually equal that. So what I can do now is add these up and set it equal to 360 because that's the whole way around the circle. And I'm kind of going off into 14 space there, but I would combine like terms. X would be 0. So if I wanted to plug that back in to find arc DEG, 2 times 0 plus 200 would just be 200. So I know there was a lot thrown at you there. As always, if you have any questions, concerns, come in person or email me. These are some tricky problems. I'll always be willing to get more help if you need it, whether that's through other videos or through myself. Have a great day.